Hello dear students, let us try to solve this question. This question says a parallel plate capacitors of capacitance C has a spacing D between the two plates having area A. The region between the plates is filled with n dielectric layers parallel to its plates, each with thickness delta is equal to D by N. That means, let's say this is the separation D and the area of the plate is also equal to A. We have here n dielectric layers and each with thickness delta equal to D by N. The dielectric constant of the mth layer is given to be Km is equal to K into 1 plus M by N. That means the dielectric constant is a variable term here for a very large n, that is greater than 10 to the power 3. The capacitance C is alpha into K epsilon naught A by D natural log 2, the value of alpha. That means we have to find out the C equivalent of the system, and after we get the value we will have to compare it with the given expression and find the value of alpha. So for that, let us take one element or a layer at a distance x whose width is, let's say, dc, whose width is dx. Now the capacitance of this layer, the elemental capacitance of this layer will be equal to K epsilon naught A by dx. Now this entire capacitor is made up of infinite number of such layers, so in order to find the net capacitance we will have to apply the series combination formula over here, and that says that 1 by C will be equal to integration of 1 by all such dc's, and if we solve this further, this will be equal to integration of 1 by K epsilon naught A. K here is basically the dielectric constant of the layer, so this is K epsilon naught A into 1 plus M by N by distance, which is equal to, let's say, dx. So we have used the dielectric constant to be K into 1 plus M by N, which is given in the question. So this layer is at a distance x, and let's say this is basically the mth layer. Let's say this is mth layer. So for this we can say that the value of x will be equal to m times the thickness of one layer, that will be equal to d by n. So from here we can say that m by n will be equal to x by d. Now substituting this value of m by n in the integration, we can say that this will become now dx by K epsilon naught A into 1 plus x by d. And solving it further, we have d by K epsilon naught A into dx by d plus x. Now here we can say that the value of x will vary from 0 to d. Now this value is equal to d natural log of 2, applying the limits here, divided by K epsilon naught A. Since this is the value of 1 by C, so we can say that C will be equal to inverse of this, which will be equal to K epsilon naught A by d natural log 2. Now comparing it with the expression given in the question, we can say that the value of alpha here is 1. So we can say that 1 is the right answer for this question. So we will write 1 as the answer of this question. Thank you.